Hey guys, this is question FM098 of the Further Maths Sharpen Study Guide. Jumping straight in, the maximum and minimum speed at which a Year 12 student threw their textbooks across the room on each of the 15 days leading up to the exams was recorded in the scatter plot below. So we've got the scatter plot here. They then say the correlation coefficient for this data is R equals 0.444. And the equations of the least squares regression line for this data is max speed equals 35.6 plus 2.45 times the minimum speed. Now that regression line isn't actually in that scatter plot, which explains why the first question A says draw this least squares regression line on the scatter plot above. So guys, number one, super important because you could use this and then go on to say, well, the y-intercept is at 35.6, and it is. However, our graph is limited to 10. It starts at 10 here, and as we can see, this is 60, 55, and 50 here. So we've got to make sure that what we plot on this graph here isn't actually going off of the y-intercept of 35.6. It would be somewhere, down here, but actually figuring out what the value of y is at this point. And then probably the way I'm going to do it is I'm going to figure out the value of the max speed when the minimum speed is 10, and then the value of the max speed when the minimum speed is 20. Plot those two dots and then draw a line between them because that'll give me that regression line. So how we go about doing that, I'm going to just write max instead of max speed equals 35.6 plus 2.45 times 10. And if you whack that into a calculator, you're going to get a value of 60.1. And then I'm going to find my max speed when my minimum speed is 20 by going max equals 35.6 plus 2.45 times 20. And when I put that into my calculator, it's going to give me 84.6. So I've got 2 points. I've got one just above 60. So here I can put a little dot just above 60, and 84.6 just below 85. So at 20 over here, just below 85. Now I can grab my ruler and connect those points up. Cool. And there's my regression line. That's part A. Part B then goes on to say, interpret the vertical intercept of the least squares regression line in terms of maximum and minimum speed. Cool, so remembering that our vertical intercept isn't actually here, we can see from our equation here that our vertical intercept, when our minimum speed is 0, our max speed is going to be 35.6. Which doesn't make a hell of a lot of sense considering that if there's a maximum speed of 35.6 then the minimum speed would have to be at least 35.6 as well. It can't possibly be 0, but for the sake of this exercise we're going to say that it does work. Part B, on average it is predicted that, so according to this line here, on average it is predicted, I spelled predicted right, that when the minimum speed is 0 kilometers per hour, the maximum speed is 35.6 kilometers per hour. Awesome, and you can double check this by substituting 0 in for minimum speed in your equation. Your max speed is going to come out, since this will be 0, it's going to cancel out at 2.45, you're going to be left with just that 35.6, and that's going to be your maximum speed. So this is just saying that on average, according to this line, it is predicted that the minimum speed is, when the minimum speed is 0 kilometers, the maximum speed is going to be 35.6 kilometers. Excellent. All right. So let me pull this out. Next question, question C, wants us to describe the relationship between the maximum speed and the minimum speed in terms of strength and direction. Cool. So our correlation coefficient up here of 0.44 is between 0.25 and 0.5, which means that we have a weak correlation or weak strength. And this is obviously a positive relation, not a negative. So we're going to say weak and positive for question, sorry about that, for question C. Excellent. So moving on to question D. So interpret the slope of the least squares regression line in terms of the maximum speed and the minimum speed. So coming back to here for a second, our equation is as so: max speed equals 35.6 plus 2.45 times minimum speed. So this is going to give us an answer along the lines of on average. Now this on average is important because, of course, the least squares regression line that we have, if I bring it back for a second, this line, obviously the points of data don't fall on this line all the way across. It's not a perfect representation of the data. It's just saying, like, on average, this is what happens. So it's very important that we start our sentences off with on average, unless we do have like a series of perfect data, so everything's going up exactly with the gradient. But otherwise, it needs to start with this on average when we're talking about interpreting slopes and that kind of thing. So we're interpreting in terms of the maximum speed and the minimum speed. So on average, it is predicted that max speed increases by 2.45 kilometers per hour for every 1 kilometer per hour increase in minimum speed. So you're just stating that, like, for every 1 unit increase of your explanatory variable, there is a, well, in this case, a 2.45 unit increase, the units being kilometers per hour, in our response variable. So we're just comparing 1 unit on our x-axis compared to how many units on our y-axis. That's what they're asking for here when they ask us to interpret the slope of a least squares regression line in terms of the response variable and the explanatory variable. Excellent. So on to part E. So E says, on the day that the minimum speed was, sorry, I'm reading question F. On question E, it says, determine the percentage of variation in the maximum speed that may be explained by the variation in the minimum speed. So they're asking for the percentage of variation in the response variable that is explained by the variation in the explanatory variable. So to do this, we're going to need R squared. However, what they've given us is R. So this pen's dying on me. So R in this scenario is equal to 0.444. So to get to R squared, we need to square both sides. So R squared is equal to 0.444 squared, which when you whack that into a calculator, it's going to give you an answer along the lines of 0.197. They want, which of course would come out to a percentage of 19.7%. However, they want an answer to the correct to the nearest percentage. So we need to round up to 20%. So 20% of the variation in the maximum speed can explain the variation in the minimum speed. And lastly, part F. So, on the day that the minimum speed was 14.8 kilometers, the maximum speed was 74 kilometers. Determine the residual value for this day if the least squares regression line is used to predict maximum speed. Write your answer correct to one decimal place. So of course, guys, we're going to be using the residual value equation. So I'm just going to abbreviate there. So that's equal to actual value minus predicted. So our residual is our actual value, we know that to, according to this, where are we? Our actual value here is 74. However, we need to find our predicted value. So in order to find our predicted value, that's going to be equal to our regression equation from before. So we're going to be taking our minimum speed and putting it into our regression line equation. So that ends up being 35.6 plus 2.45 times 14.8, because that was the minimum speed on that day. So the predicted value for maximum speed is going to end up being 71.86. So then to find our residual, to abbreviate to resi, that's going to be our actual value of 74 minus our predicted value of 71.86, which is going to give us a final value of 2.14. And they want the answer to one decimal place, which means that we're going to round this to 2.1. And there you have it, guys. So if you have any questions about this question, this is a long one, lots of different things going on. If you have any questions, drop them in the comments below or hit up our Facebook page, Triumph Tutoring, and shoot us a message, make a post, whatever works for you, and someone will be sure to help you.